about variables expression in a statement to some extent, starting with the constants. So what is a constant? So this constant in other languages is called literals. We hear this a lot from time to time, literal. So when we're dealing with a constant, it's easily understood. If this is an integer, then this is an integral literal, okay? Or this is an integral constant, right? And this 98.6, now there's actually a designation, a name for anything with a decimal point associated with it in programming, in computer science. You guys know what that is? I know not a lot of you like to talk. We'll get used to it. So this is what we call either float or double, okay? And 1, 2, 3 is what we call integer, okay? And what about this hello world with a colon associated with it? Not colon, apostrophe.
String.
Yes, this is what we call string. Oh, sorry about that. Let's go back here. Okay, this is what we call string. In Python, you can use double quote as well. You don't need to use single quote. So single quote, double quote is the same thing. So Python is pretty loose, just like JavaScript, okay? So you have string, you have float, double, and integers. Now, the constants are, as you expected, anything that you spell out, right? So 98.6 is a float constant. 1, 2, 3 is an integer constant. Hello world is a string, is a character. So string is a collection of characters. Anyway, let's talk about float and double. So float and double, there's actually a huge difference between the two. You probably come across these things, but typically we like to use float because it's smaller. Float in general, it's a integer with decimal points that goes up to about 7 to 8 decimals, okay? So it's pretty big. Now, 3.14159, right? That's only 6, right? When you get to 7, that's pretty much the kind of the maximum space that is capable of storing a float. Now, double is double the size of float, basically. So double actually gives you the ability on your 64-bit computer to up to about 15 to 16 digits past the decimal point. So double is something that we do quite a bit. If you want scientific precisions, you can store something in double. Otherwise, a float would be just as fine, okay? So that is the constant, just from a kind of a quick intro standpoint. Let's move on to the next one. So the next one is the reserved keywords. These things are reserved, so you cannot use them as your variable names, okay? So if you can create something that using for, your code is not gonna fly. Lambda is something that's very new, while not, right? So you don't have to memorize these things, but if you use an ID, like I said, you're gonna see different colors showing up there, signify that this cannot be used. So ID is gonna help you. ID stands for Integrated Development Environment. Okay, so a variable is a name placed in memory, like I said before. So what's gonna happen is, actually, let me just draw this, okay? When you first boot up your computer, you see this memory cloud, or you don't. This memory cloud is part of your 64 gigabytes of memory chips, whatever you have, okay? So today, you might have 32 gigabytes of memory stick. That 32 gigabyte goes into your CPU, goes into your computer, and that runs in conjunction with your CPU. Your CPU boots up, your operating system gets loaded. Now you got everything there running, and you have this cloud, okay? So I just drew a cloud in front of you here. This cloud may have 80% of that 34 gigabytes of memory space. Fine. What happens is when you do this, x equals 12.12. So basically, a couple things happens. When you put x in here, it's telling your computer, okay, to your code. Actually, your computer means your program. Your program is telling your computer to go into your memory space and look for this particular spot. Now, this particular spot happens to have sufficient memory that is capable of holding this. So I'll be super frank with you. This is a float, okay? So what is a float? Oh, I'm sorry. No, please undo. Okay, a float, it's an 8-byte. Sometimes it's 16 bytes. A variable, not variable, it's a type. So if I put things in perspective, 8 bytes, it's is 2 to the 64. Okay, so this is actually 2 to the 64 in size. So what is 2 to the 64? So 2 to the 64 power, okay, is a large number. I think I forgot how big it is. This could be in the billions. Actually, it's in the tens of billions, I think. But anyway, this is how many different integer or integral values that you can store in this particular amount of space. Okay, this many ones and zeros, so to speak, combinations that you can have. So it's a pretty large amount of space that you put 12.2 in it. So this is 8 bytes. So there's actually, what happens is there's actually an 8-byte memory space. So this entire space here is 8 bytes. Okay, so I'm gonna just write 8B here. So 8 bytes. Actually, no, if I just do this, and I'm sorry, I don't, this is not a blackboard. This is my mouse. So it's 8 bytes, okay? This is 8 bytes. Now, there's this little area here, and this area is the memory area. So there's actually a memory address associated with this. So this one is, let me use this. So this memory address is usually a hexadecimal. I'm just gonna call it x times 0f13 or something like that, right? So when you punch this hexadecimal number into a scientific calculator, you get back an integer, which is fine. Okay, so what is it saying? So I just made up this whole 8-byte structure that has this memory address. This x equals 12.2 actually happens. First of all, your program is going to look at what is the x? Well, x is a float because your right-hand side, like I said, decides on the type of this float, this data type. Float is 8 bytes, right? So your computer is going to go into your cloud and looking for that consecutive chunk of memory that is good for 8 bytes. So boom, right? After several thousand iterations, and this is all happening in milliseconds, probably nanoseconds, it finds this space with 8 bytes, sufficient memory that you can store your 12.2 into it. What happens is x is then assigned that space at this location, 0 times ZF13. And then 12.2 is then slotted into this area, 8 bytes. As this value, right? So on one hand, you have this x, which is a label for this particular memory space. And then if you actually print the value of x, you see 12.2 into it. Now, the reason why you can do that is because 12.2, which is a float, is being stored into an 8-byte structure that calls for a float type. Okay, same thing with y, but the difference between y and x is y actually takes up only 4 bytes. So there could be another space identified somewhere here for y, and this y is sitting at this other location with a different memory address. I'm not gonna, well, you know what? Since I'm at it, so this memory address might be 0 times f1. It's completely different from the previous one, right? And this one is 4 bytes. Okay, so I'm gonna say this is 4 bytes. Now this 4 bytes is gonna have what? It's gonna have 14. This value of 14 into it. Okay, so why am I going so far going through these things? The reason why y is only 4 bytes is because 14 is an integer. Integer is different than a float. Integer is 4 bytes on a 64-bit computer. So you can do a size of, I think in Python, there's another function that you can use, print out number of bytes associated with it. But that's generally happens, what happens there. Now, you don't really have to memorize, this one is 4 bytes and the other one is 8 bytes. No, that's okay. I go through this in depth for my C++ class, but just realize that, you know, when variable is a name placed in a memory, what does that mean, right? A name placed in memory. This is exactly what I just illustrated in red, okay? So a variable actually has a memory locations, and the value associated with that is whatever is assigned to it. So in this case, what gets assigned to x is 12.2. What gets assigned to y is 14, okay? So just by looking at the constant, you can see 14 is an integer. This one is 4 bytes, and float is 12.2. So actually, when you ship 12.2 into this 8-byte structure, you're gonna have 12.2 and a whole bunch of 0 at the end because there's nothing after this 2, right? It's all zeros. So that's what happens. Your program actually pad these areas with zeros. Okay, you can change the content variable, like I said. Right now, this one is stored 14. This y is stored in 14. Later on, you can have it changed to 16 or minus 20 or 40 or 60 or 2058, right? Something like that. So that's another property of variable, and that is variables are reassignable. So it's totally fine as long as they're not declared with a constant as a constant. You can reassign values to it later on. Okay, so that's variable. And notice that there is no type. So you don't have to specify the type of x, y, and x, x and y beforehand. You can, oh, this is a variable assignments here, reassignment. So, so good news is about Python is Python would determine the type of your variable based on what is on the left-hand side, on the right-hand side, okay? So RHS, right-hand side. So the right-hand side, the type of right-hand side determines the type of the variables. So in this case, X is gonna occupy 8 bytes, Y is gonna occupy 4 bytes, okay? One good thing about this is the variables could be, their value could be reassigned. So what happens is when you have equalities here, to the right of equalities right-hand side, to the left is the left-hand side, your variable name has always to be on the left-hand side. The equations, this equality sign basically says assign or attach this value to the location where this X is located in memory. Okay. All right, so I think we had enough for this one. Let's move on to the next one. Naming conventions. So yeah, you do not. And in fact, when it says bad, this means it won't even compile, okay? So you cannot have a variable that starts with the numbers here. It's totally not valid. And any period or commas or something like that in between the variable name, no, right? So do not do that. So what is good here? Typically, and I keep telling students, the best practice for naming a variable is if this variable is for doing such and such, spell it out, okay? If you ever worked for and heard some stories from people who, engineers working for Apple, Apple has a company standards. If you ever looked into their Cocoa code or iPhone, which is Objective-C, codes, you see a lot of these functions that is extremely long, you know, like 33 characters. It basically says this variable is for doing this, right? So if you spell out the whole thing, you know, your variable name is like, you know, 30 characters. But that's why engineers working for those companies, they learn how to do Control-C, Control-V a lot, right? And there's no way in hell you're gonna write them out from the beginning. That's a lot of work. Anyway. Sometimes people use what we call camel casings. So you can say CIS 12 students, right? So camel casing means at some point you're gonna see a capital letter, everything else is lower, right? So it's kind of like bump, right? At some point you're gonna go up, and then later on you're gonna go down, and then it's gonna go up again, right? Or grade for students, right? So you can see camel casing here, right? F and S is big. So some companies actually do that. I do it myself. And some places where you see people doing underscore, and everything else is going to be smaller case. So this is another thing that you can do. I'm sorry, this is great for students, not G. Okay, I can't change it now because I'm using annotator. This is pretty bad. Yeah, so these are the good practices that you see a lot of times, and sometimes you see underscore. Underscore means internal, which means it's local and it's not global. Okay, so this means that this belongs to this entire file here, but not the entire program. So you can do that something like this: letters, numbers, underscores, or camel casings. So it's case sensitive. So if you spell something, you know, with a capital S, and you ended up doing small s and not uppercase but lowercase, that is considered two different variables. Okay, so just make sure that that you're aware of the casing as well as the combination of these letters and characters. Any questions about this? Okay. All right, let's move on to the next one, which is mnemonic. Mnemonic variable name. Okay, I'm not a huge believer of this, but yeah, I mean, this helps you um, to name your variables. Go ahead and do that. But yeah, I mean, what I don't want to see is you name everything A, B, and C, right? Or X, Y, and Z. Sometimes students do that, you know, or X, when they run out of the A, B, and C to Z, you're going to start seeing AA, BB, CCC, right? Don't do that because these variable names don't mean a lot to me, to you either, right? So two days later, you come back and you'll be like, what did I just do? What is ZZ? What is ZZZ? You know? So you want to do something that makes sense. Anyway, so I think that's kind of common sense. And what is not really common sense is this. Somehow, have you guys ever used, you know, ever sign up to a website and then, I don't know, some of you may be using iPhone. Maybe this is true in Android as well. That iPhone would make, you know, this iPhone, it'll actually create a password for you. You know, it says strongly protected, right? It asks you whether you want to use it or not, and it'll generate something that you never be able to memorize. And then, of course, next time when you log in, your iPhone is never gonna remember that password again, and then prompting you for a password reset. I don't know if you guys had any of those experiences. It's very frustrating. That's kind of like doing this, you know, like selecting this password looking variable name that you never use. And later on, you're gonna have to learn how to cut and paste and control V's, control C's. It's very frustrating. So don't do that, right? Don't ever come up with a variable naming conventions like this. It's bad. Okay, it's not like you got highly sensitive stuff that you need to encode for later use. Okay, I think that's common sense. Yes, and yes, and don't do A, B, and C's, please. Come up with something that is more meaningful, right? If A is time, right? Or B is number of hours, just say it, you know? Kind of like if you say number of hours, how are you going to translate that into a variable name? Num hours, right? Okay, something like that, right? Or number of hours if you want to write them out like this. Totally up to you, but don't use A, B, and C. Okay, that's what I wanted to say about variable. We can move on to, yeah, I think this, the author is teaching you exactly what I'm talking about. Okay, sentences or lines. Assignment statement, I believe this is from lecture 1, so we went through this kind of already. But just remember the equal sign here. This is what we call assignment, okay? You're assigning the value to this variable. And then you're assigning this expression, right, to this variable. So what is the expression? Expression is a combination of what we call operands and operators. So operators are plus sign, equal sign, minus sign, multiplication, division, modulus, stuff like that, okay? And operands are what's available besides, when you have an operator, you have operands on both sides, right? So, or you can have maybe operand on one side. So one example is x plus plus, right? So that's operator. That's a unary operator. But what I'm talking about is, in a generic sense, you have two operands here. So in this case, you have x and 2. So these two are what we call operands. And when you have an operator in between, these operands and operator combinations is what we call expressions. This is what we call expressions, okay? So this entire thing is expression. Expression typically results in some sort of Boolean conditions. It's a true or false. Why? Well, remember in computing, everything is ones and zeros, right? So everything is a value, right? There is a value associated. Even a string itself has value, right? Which is whatever you can spell them out, array of characters. But for an expression typically results in some form or another, some value, some constant, and that constant is then assigned, right, to this left-hand side. So that is assignment with expression and print statement, assignment statements. Any questions about this? I hope this is pretty straightforward. This is the very first time that you guys are running, doing programming. You know, this might be a little different, but I think some of you probably had some AP computer science, right, classes before, or maybe some programming classes. Hopefully, right? you should be able to grasp this pretty readily. But if not, then let me know. Okay. All right. Assignment statement is something that gets assigned. So usually the expression itself evaluates to a number, and that number is assigned, right? So whenever you see a statement like this, right? A statement is a combination of assignment and expression. The entire expression, okay, or the entire statement evaluates from this order. Basically, what gets evaluated first, okay, is your expressions here on the left-hand side. On the right-hand side, I'm sorry, right-hand side is evaluated first. Okay, right-hand side, number one. What is on the left-hand side? What is it? Is number two. Okay, so basically the value goes in there second. So basically the whole flow is your expression is evaluated, and then the second flow is when the assignment happens. So the third flow is when this is actually three. The left-hand side, the value substitution in that case, or value replacement happens as a step three. So this is a three-step process. When I said the evaluation of your interpretation happens from left-hand side to right-hand side, is actually the other way around. Okay, but the evaluation, generally speaking, when an interpreter looks at your code, is from top to bottom. Okay, any questions about assignment statements? Okay, all right, the next one. Variables is a memory location. We talked about that before. That has a value. So basically what happens is when your x is first defined, it has a value associated with it, right? Let's say if this x is 0.6. So that's fine. At some point, well above this code, you have something like this. Okay. All right. So maybe the second line shows this. So you have this entire expression, and like I said before, the right-hand side of your expression is evaluated first, right? So when it gets evaluated, what happens is there's this called arithmetic precedence. So basically what that means is your interpreter is going to start looking for this parentheses. Whatever is in the parentheses has the highest precedence, meaning order. It will be treated first. So 1 minus x is actually looked at first, okay? This entire block, because it's parenthesized, is evaluated first. So if x is 0.6, then 1 minus 0.6 is 0.4, right? So this one is actually evaluated first, 0.4, right? Okay, so that's cool and dandy. What about this multiplications? And there's actually two multiplications here. Now, this multiplication is the same as non-multiplication, so it doesn't really matter which precedence, which one has the highest order. They all have the same order. So you can evaluate 3.9 times 0.6 first, or 0.6 times 0.4 first. Doesn't really matter. Your program actually takes care of that. So whatever your outcome is, which is 0.936, this one is the outcome of your expression on the right-hand side, is then assigned, okay, because of the equal sign. Equal sign means assigned, is assigned to this value, to this variable x that has some memory location somewhere. Does it make sense? Okay. All right, so the very next one. Yeah, so I'm not gonna go through this because I already did. The expressions is usually comprised of these operators. Plus, minus, you guys need to go through this. Plus sign means 1 plus 1, right? Subtractions, right, minus. Multiplication, and then division is actually this one. This is a forward backslash, okay? This is not your backslash. This is your other sign. And make sure that you don't get confused. This is not backslash. All right, and this is a forward slash. Power in Python is stars. Okay, so if you want to write 2 to the 64 power, like I said before, right? 2 to the 64 is like this. How would you write it in Python? 2 * 64, right? Okay, so yep. And what about this? What do you call these things? Percentage sign, modulus. Yes. So what does that mean? Well, remember when you divide something, a number divided by another number, you get two things, right? One is the quotient, and the other one is remainder. A quotient is the multiplicator, right? But the remainder, which is your modulus, this is the remaining amount. So if you do 100 mod 2, you're going to get 0, right? Because 100 mod 2 is the result of having 100 divided by 2, right? That gives you a quotient of 50, a remainder 0. So that modulus is actually it's going to give you the remainder, okay? So 10 mod 3 gives you 1, right? So that mod, like 10, right? And then if you do this mod right there, 3, what you get? 1, right? So this one is the remainder, okay? So this one generates the remainder. All right, so any questions about this? If power is star star, is the caret reserved for something else? Yes, it is reserved for something. Actually, in fact, I don't even know if that is valid, the caret. So that caret is good for Java in C++. But we're in Python land, Pythonista land. So everything is different. Why? Well, because whoever created Python says so. That's the load of assertions here. Okay, let's take a look. So, okay, so did I say that you shouldn't be using XX? Now this manifested itself. It's almost like I'm foretelling a story here. So x is equals 2, x is plus. Okay, so this one is going to give you 4. Why? Because x here is 2. 2 plus 2 equals 4, and then the expression is evaluated. That gives you 4, and then the assignment says store that value, whatever this evaluated value is, which is 4, into XX. So when you print it, you get 4. Same thing with YY, right? So you can follow the kind of the flow here, and then printing out ZZ. Okay, so what is ZZ? ZZ is this. Of course, you can do JJ and KK, blah, 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 and just keep going. So 4 to the power of 3. So this is 4 times 4 times 4, right? 64. Okay? All right. Not really sure what this is, but that's okay. It looks like this is for, yeah, you can use a caret for smiley face, but smiley face is not going to compile, so you have to put it in the comments. Okay. Any questions about numeric expressions? Okay, so you guys have done math before. The only difference is all of the hulu colored, green colored variable names, and everything else is all arithmetics, grade school arithmetics. Okay, like I said before, the president, right? It's when I say presidents, I'm not talking about Donald Trump here. I'm talking about the operator presidents. Okay, presidents as in the order of evaluations. When we use string operators together, Python must know which one to do first, right? So what do you think this one, like what is the first one here, like on the bottom here? Typically the exponential carries a very high precedence, and you have to know that the plus sign. So for sure, right, this thing is almost like, you know, having a bracket here, parentheses, and then this, right, kind of happens first, and then you can see that if once this is evaluated, and it becomes a plus and a minus, right? It doesn't matter which one is first. So plus and minus both have the same precedent. So overall, you kind of have to know anything that is more advanced than plus and minus is going to have higher precedence, which means they're going to have to happen first, right? And then the rest kind of just follows. Now, as a rule of thumb, as the best practices, you would want to use parentheses as much as you want. I think it's much better because it also conveys, you know, to other developers who may not know about the order of precedence or cares too much about it, to really know what you're doing. So for the better maintainability of your code, you would want to document this or use parentheses as much as you can, even though it's kind of obvious. It may not be obvious to other people, okay? Any questions about the order of evaluations? How many of these? We're about halfway through. Okay, so order precedence rules, parentheses over power, over multiplication, over addition, and left to right. Does it make sense? So what does left to right mean? Left to right has the least precedent, which means if you've done all of the parentheses lookup, power, and then manipulation, multiplication. Multiplication means division too. Okay, addition is the same as as subtractions. So if you've completed all of these operations, then the last one that your operator precedence rule is left to right, going from left to right. Otherwise, it's right to left. Any questions? Okay, here's a couple of illustrations here. I really didn't mean to want to kind of bore you with this, but I think it's very important. So this, as we know, exponential, it's kind of, where is it? It's somewhere, power, right? So power actually takes higher precedence than multiplications. So this means that since I don't have parentheses, I go for the power. So this power has to be evaluated first, right? Which is exactly what happens, which results in 8, right? This thing results in 8. And then what happens is you have division and multiplication. So this division and multiplication both have the same precedence. So you can actually do this, or you can actually do this. Doesn't really matter, okay? But the order is from left to right. Okay, fine. So we follow that rule. And then 8 divided by 4 is going to give you 2. And then you have multiplications happening at the same time before your plus, right? And that's how this order goes. Does it make sense so far? This is how you get 11.0. Can anybody tell me why this is 11.0 and not 11? What do you think is the case? I mean, this is very strange, right? Why is it? I'm starting out with a whole bunch of 4 bytes, and all of a sudden I'm getting like a flow, which is 8 bytes. Something must have been wrong. What do you think? No takers? Like I said, this can happen first, right? Is it true though? Can this 4 plus 5 happens first before this divisions? I don't think so. Right? Because 8 divided by, this is like 20, right? 8 divided by 20 is going to give you a fractional point, which is not the same as 2 times 5. So this left to right rules actually happens as well. So the evaluation of your code goes from, I must take care of what I have here first before I can take care of the rest. Okay, but the question is, fine, I'm going through this ladder, this tier or caste structures here, eventually getting to 11. How come this result is not 11 by 11.0? So something must have happened, right? Something is thinking that this is dealing with a large number with the decimals versus the 11. Okay, so this is one of those idiosyncrasies in Python tier 2. When you have a whole bunch of plus and minuses, also divisions, subtractions, and exponential or power. By default, Python looks at these and thinks that I need to have a much larger structure. So because the chances of you getting a decimal is pretty large, it will convert this x to be a value, even though this whole expression evaluates to an integer, which is 4 bytes. Python actually gives you and turns this automatically into a float. Okay, so the result is 11.0, which is fine, which is 11 with a whole bunch of zeros, right? At the end, where the decimal takes place, it's all zeros, padded with zeros. Make sense? Okay, cool. Let's move on to 21. It's getting very, very interesting here. The rules from top to bottom. Okay, so I'm not going to reiterate the same thing. Parentheses, power, multiplication, addition. So you should know about these things. If you don't know the certain precedence, which is fine, just use a whole bunch of parentheses as a best practice, like I said before. Okay, so what does type mean? Okay, so in Python variables, literals, and constant have a type. So we kind of talked about that, right? The difference between 4 bytes and 8 bytes is the difference between type. One is the integer and the other one's float. Okay. So the same thing can happens when we're dealing with an integer number and a string. So string in C++ and most of the in C++ is 24 bytes. It's a class. I think Python is the same thing. String is a collection of characters, but it's actually a method associated with a string. And those of you who have done your homework, you know, split is part of the string method. So string itself is a class, which takes a lot of space. Okay, Python actually knows the difference between the two because you're doing this, right? Because whatever is happening on the right-hand side, which is your expression, evaluates to something, right? So when you have a string, right, plus another string, now this is very curious. A string is a collection of characters. How do you do arithmetics with two strings? Well, it turns out that this plus is actually a string function. Now these two strings looks very, very not like a class at all, but a string itself is an object in Python, and by virtue of having a plus sign means you're concatenating two strings, and plus sign is a in C++ what we call overloaded operators. That is what we called a static polymorphism. But anyway, I'm going a little too deep into it. Just think of this plus, even though it looks like a arithmetic plus, right? Additions. No, it's not. This is actually a function that takes two arguments. One is the hello, and the other one's there. Both arguments are strings, and plus concatenate them, meaning they stitch both together. Hello with a space is buffer 1. There is buffer 2. So when you put both together, you create a third buffer that has sufficient amount of space to accommodate both of them. And so character by character, hello, space, and there, character by character gets shipped or created into this third buffer. And then the outcome of that third buffer is the concatenated string that gets saved or shipped over or assigned into this EEE variables, okay? All right, if the addition operator received two string as parameters, okay, it concatenates, very nice. Yes, that's correct. Okay, so what is that talked about is what is plus is. So this means addition, okay, but ultimately plus is a function. All right, anything else about this page? If not, then next one, okay? Cool, the type matters. Yes, so what does that mean? Well, if you have the wrong type, then you can't do nothing. Well, actually, you can't do nothing. It's a double negation, which means you can do something, which is not what I mean, but you guys know what I mean. EE equals hello plus there. Okay, so now you have concatenated a string here. And then all of a sudden you have EE equals EE plus 1. Now this is a problem because EE is a string, okay? So string plus 1, what does that mean? Well, can convert integer object to string implicitly, right? So when you have a string, which is EE, right? We kind of know already here. You have a plus 1. So this is a type plus type issues here. So integer cannot be added to a string. You cannot add 1 to a string. This is a problem. So you get what's called exceptions. This is a type error exception. It's very common. Runtime error. Runtime error is something that happens after you interpret your code at runtime. You can ask Python what type of this is. So it's kind of like in C++, you can actually type kind of print out a type of your variable. You can do that with a type function. This type function again is global, and then if you do that, you can see the actual class. So you can see that string is actually a class called string, str. Okay, integer is of class integer. So these integer are reference classes. So these are reference classes too. Okay, so hello is a string, e is a string, but 1 is an integer. So if you type 1.0, type parentheses 1.0 parentheses, you're gonna see class float. Okay, class float. Okay, so any questions about this? Type matters. Okay, so the very next one, several types of numbers. Yeah, like I said before, this one is float. Yeah, I think I mentioned this a couple times. So float can also have a negative numbers in associated. Same with integers. Okay, so both these integral, what I call integral types, they go both ways, left and right, meaning left all the way into the negative realm, or the positive that goes into the to as far as flow can accommodate size-wise. Okay, 25 type conversions. Now this is interesting. You can add both of these. So what happens is, like I said, flow it's of a much larger type than integer, right? So what would happen if you plus them? So this thing plus this, very simple. What happens is this 100, which is you can think of it as a smaller type that occupies only 4 bytes, but 99 is a float, right? It occupies 8 bytes. So when you have 8 bytes plus 4 bytes, and guess what happens? This thing will be converted into an 8 byte, okay? Like 100 here, okay? And then there's like a whole bunch of this space that gets added here, right? And this is all going to be padded with zeros, which is fine. Dot 0, 0, 0, 0, right, all the way through. That way you have float plus float, okay? So this is what we call implicit conversions. This is what we also call upcasting, because you're casting it from a lower class into an upper class. So this way you get a whole bunch of zeros as a padding. Now, if you're talking about conversions, it could also be a downcast. Downcast means going from a much larger type into a smaller type. And if you do that, then that type of conversion is what we call downcasting. You're going to lose precisions. Basically, originally you have 8 bytes, and then you cut it into 4. So basically what happens is all of your decimals, they will be kind of truncated, right? So when truncation happens, your number is no longer true, right? As your original. It's kind of like 3.14159, and then you truncate, 159 at the end. So you ended up with 3.14. So that truncation loses precisions, which is pretty bad in programming because you get different results. Okay, all right. Type conversion can be implicit. It could be explicit. So this is the explicit. Okay, so what does that mean? Well, explicit means that you're calling it, you're converting this I forcefully, right? This is kind of like a mandate that you're asking. This type I, right, is an integer. Now you force the conversion into a float. So when you print this out, now it's gonna have 42.0, right? And then if you do a type on F, it's gonna be float because you kind of cast it. This is what we call casting, okay? Right, flow equals that. So in some languages, you see something like this, right? Okay, with this statements here. This might be the case with C++, but in Python, you have to call it the float function and the variable, okay? All right, so any questions about type conversions? The very next one, integer divisions. Okay, so integer division is very interesting. Now, when you do 10 minus, right, divided by 2, like, why am I getting this? Like, integer divided by integer, how come I'm getting a float? Like I said, this kind of goes back to what we talked about earlier before, right? There's a strong possibility that when you do these arithmetics, you end up with the integers. So automatically, having done this integer division gives you a floating point result. Now, this was different. Yes, this was different in Python 2, believe it or not. It's what happens in Python 2.x is similar to what you see in C++, where if you do 10.2, you get integer results. 9, if you do 9 divided by 2, what do you get in Python 2.x? What do you think? If this happens in Python 2x, what did you get? You actually get 4, okay? And if this happens in Python 2x, you're gonna get 0. Okay, why? Well, because the division actually gives you the unrounded quotient, right? So the quotient for this one is 4, right? Forget about the 0.5. I know you can round this in, right? But I'm talking about unrounded quotients, right? So this thing divided by this is going to give you 5, right? So in Python 2.x is very different results-wise. The Python 3 actually gives you a lot more control. Okie dokie. Page number 27, string conversions. Oh my gosh. Okay, now we're talking about string here. If you do a string type, you're gonna get str's class. We already know about that. And then we know we can't do this, right? Okay, that's fine. What we can do is we can convert a string into a evaluation here. Can you do that? Yes, you can. If this string is a alphanumeric, right? If this string is a alphanumeric, which not alpha, but numeric, numeric string can be converted. Numeric string means I have a string 1, 2, 3 that can be converted into 1, 2, and 3. Then you can invoke this one. If not, like this, you know, can you convert a collection of characters that it is not integral? No, you can't, right? So you're gonna get this conversion problems. Now, I can ask you to write a generic integer conversions functions for Pythons. You can actually do this from scratch. If you don't have a numeric string, then this integer conversion is gonna error out, okay? Any questions about string conversion? Okay, so what you see here is all Python interactive. Okay, all right. Here's the interesting. So here's the input. So what is the input here? Now, in the context of your computing device, your input is whatever is in your keyboard. Okay, so this input actually points to your keyboard. When you have this input, so you're basically telling Python to pause and read data from the user using input functions. In this case, you're not asking the you basically. So okay, so basically what this is doing is returning whatever the labels you have, but after that is waiting for user input. So in Java, it's called scanner. You can use scanner to go for user input to listen for it, not go for it. In C++, it's what we call cin. Okay, so there are differences. In Python, it's what we call inputs. So these input, if you don't enter anything, let's say if you don't enter this yellow chuck, your cursor is going to stay on the C area, and it's going to just stay there forever, indefinitely, until you die. No, of course you're going to want to do something, right? So who are you? And then you're keying something, that's fine. Then the next line of your code is going to be unblocked, meaning the flow of control then goes into the next line, which is print, welcome, and whatever was entered. Okay, so what you just enter chuck, this actually gets saved into this nam, right? And then you can print welcome this name, right, at the same time. So print actually takes arguments concatenated, separated with a comma. Okay, not period, but comma. Excuse me. Any questions about this? Okay. Let's move on to the next one. Converting user inputs. Yes. So sometimes you don't know what a user is going to input. But in this case, you basically have to tell the user, please give me an integer. Okay, so if that's the case, you can convert that, because remember, input returns a string, right? So this is actually a string coming back to you, which is not good, right? But as long as you can ensure that the user gives you a numeric string, you can convert that in numeric string using using this integer conversion function, and then you can output the results. Okay, does it make sense? Now this one assumes that user is good, right? User doesn't enter bad data. So we'll talk about bad data later on when we get closer. I believe there's a chapter on error and exceptions that we can talk about. Okay, comments in Python. This is very important. Anything after a pound is ignored by Python. What does that mean? Well, you can write something like this, it doesn't matter how many pounds you have. This is my work for, and then you do another pound, CIS 12 this summer in 2020. My name is, right? So you can do something like this. So anything that you have pound, that you separate with the pound or preceded with pound is ignored by Pythons. This is why we comment. So comment is one way to style your code. It describes what's going on in a sequence of code. So this is very important. You're not the only one, even though you're writing this code, but your piece of code is not going to be maintained by you many years later, maybe someone else. So another developer, another team, another program organization is going to take over, and it's going to look at your code. And if your code does not have any commentaries, that's a very bad code. It's kind of like writing something in another foreign language that, even though people understand this foreign language pretty well, they may not understand your intent, right? So your logic, like your thought process. So if you don't do that, it's like writing a novel, right? If you don't express what you need inside a novel is not a story that could be told. So it's commenting in Python, just like any other language, is kind of like storytelling, right? You document who write the code. So if you guys are interested in taking my course, part of my course, at least 10% of my course, it's learning how to write API, right? Application programming interfaces or documentations or stylings for the solutions that you write. Okay, so this is comments in Python. Any questions about that? Okay, here's another examples here. I am a proponent of documenting as much as you need, but not all over the places. I've seen people who comment every single line of their code with a pound, which is ridiculous. I think at some point, you don't need to say for line in handles. This is kind of like iterating all of the lines in the handle, right? So I can see that here, okay? So you don't need to comment this line. So it is perfectly okay if you want to do something like this, like put a pound next to it and said, iterating through all of the lines in the handle buffer, right? Or a list. Okay. Well, in this case, handle looks like is a file, right? Yeah. So you don't want to comment. This is over commenting, but it generally it's good to comment a block of them with a pound on top of it. So as you will go through your homework assignment, you'll see opportunities where you can actually decorate your code with commentaries. Questions? Alrighty, the next one. So, okay, so let's go through what we went through today. We talked about the implicit type conversions today. We also talked about reserved keyword, which you don't have to memorize. If you have a good IDE, you would know what those words are reserved and not to use. Variable naming convention, we talked about operators. Of course, when we talked about operators, we talked about both expressions and the order precedence, right? And then what is not mentioned here is assignments with the equal signs, right? And then of course with the assignment, we're talking about left-hand side and right-hand side. And then later on, we got into the more practical aspect of your arithmetic evaluations with integer divisions as well as conversions between types. There's upcasting, right? There's also downcasting, right? Upcasting meaning I'm upcasting it to a much larger space. Downcasting means I'm shrinking, I'm truncating my integer into my flow into an integer type of deal. So upcast, downcast. One of them gives you a whole bunch of zero padding, and the other one actually reduces your precisions. And then we talked briefly about user input as well as commentaries. Okay, so this marks the completion of my slide for today.